Hello everyone. Welcome to the solution of LeetCode problem 109 named Convert Sorted List to Binary Search Tree. In this problem, we are given the head of a singly linked list where the elements are sorted in the ascending order. And we have to convert it to a height balanced binary search tree. So here, the definition of the height balanced binary search tree is a height balanced binary tree is a binary tree in which the depth of the two subtrees of every node never differs by more than 1. Here, if we consider the first example, the linked list contains element -10, -3, 0, 5, and 9. So if we convert it into a height balanced binary search tree, the root will be 0. It will have two children, -3 and 9. -3 also have one children, which is -10, and 9 has one children, which is 5. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, the algorithm is pretty simple. We have taken this example. Now at first, before running any of the DFS or in-order traversal algorithm or any recursive algorithm, we have to first extract the value presented in the nodes. So here, let's take a node dummy. It is pointing to the first element -10. So far, so good. Now dummy is pointing to the next element -3. Again, dummy will point to the next element 0. Again, dummy will point to the next element 5. And finally, dummy will point to the next element 9. Now, we have taken all of the value into a vector or into a list. Now, we have to construct a binary search tree which is height balanced from this list. So the basic algorithm is, the optimal solution is we have to add the value 0 or the mid value into the root, and here all of the value before the mid is less than 0 and all of the value after the mid is greater than 0. Now, if we make a binary tree or binary search tree which has root 0 and all of the value in the left range lies in between left subtree and all of the value in the right range should be raised in between right subtree. And this is how basically we're going to solve this problem. So here we have to use binary search to solve it. Let's see how can I do it. We know that in the binary search we have a middle pointer. Now all of the element before the middle pointer should be in the left subtree and all of the element into the after the middle pointer should be into the right subtree. So here let's make a node which has the value 0 as a root. So here it is our left subtree. Now here in the left subtree the middle is -3, so we have to make another node using -3 and we have to add -3 with 0. Now -3 does not have any of the right node, but it still have a left node which is -10. So we have to add -10 here. Now the left subtree construction is over because we have used all of the element into the left portion of the middle root. Now here we have another subtree or another portion which is right. It has two elements 5 and 9. So the middle is here 9. So we have to add a 9 and make a connection in between 0 to 9. Now 9 does not have any of the right children, but it still have a left children or left section or the left element, which is 5. So we have to add 5 as the left subtree as 9. Now, this second segment or this right segment is completed. So far, we have found this tree, which is the binary search tree formation of this given input list. And this is how basically we're going to solve this problem by using the binary search and recursively calling the tree building function into the left portion and into the right portion of the root. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named sorted list to binary search tree, which has a head as a parameter, which is a linked list. Now, we have to get all of the value from the linked list. So here we have defined this method. In this method, we are inserting all of the nodes value into the vector array. Now, after that, we are returning the generate binary search tree function. In the generate binary search tree, we are taking the vector as a parameter. Now, if the vector is empty, we have to simply return null. Otherwise, we have to calculate the meet, and our root will be the a of meet, which is the value presented in the meet index of vector A. Now, we have to take two parts. One is left part, another is right part. Left part is from start to meet, and right part is from meet plus 1 to the end. After that, we have to recursively call the generated binary search tree function into the left subtree and into the right subtree, or into the left part and into the right part, and recursively add it into the root of left and root of right. Finally, we have to return the root. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.